When we look at the global automotive industry, the Porsche 911 stands undisputed as a timeless design icon. But behind that legendary silhouette lies one of the most profitable, precise, and efficient manufacturing systems in the world. As an industrial engineer, looking beneath the surface of Zuffenhausen reveals a true masterclass in lean manufacturing, where complex custom engineering meets absolute operational excellence, proving that high margins and high flexibility. If you look at the Zuffenhausen footprint, you'll see a complex puzzle, not a single hall. Spanning over 600,000 square meters, the plant is divided into multiple interconnected lots and facilities, joined by enclosed skybridges and elevated overhead conveyors. Here, the Porsche Production System 4.0 is integrated into a modular, high-tech line. We've replaced traditional, rigid conveyor belts with autonomous guided vehicles, AGVs, and electric overhead monorails. This modular architecture allows the line to dynamically adjust cycle times while adhering to required takt times. In recent years, the global production of the Porsche 911 has ranged between 50,000 and 55,000 units per year. Cabriolet and Targa account for approximately from 25% to 35% of total 911 production volume. The main 911 assembly line typically operates on 2 daily shifts. During periods of peak demand, or in specific departments involving high levels of customization and production, is extended to 3 shifts. The total land area occupied exceeds 600,000 square meters. Let's talk about flow. Porsche operates on a highly customizable build-to-order model. Production is never pushed based on forecasts. It is strictly pulled by actual customer demand. From the body shop, every vehicle receives a unique digital ID that broadcasts its exact specs in real time. Analyzing the motorization of a Porsche 911 is equivalent to exploring the absolute excellence of engineering applied to 4 wheels. Everything comes to life from the unmistakable, horizontally opposed, 6-cylinder boxer architecture, positioned with surgical precision beyond the rear axle, a unique layout that has always given this elite car an inimitable driving dynamic. Whether considering the 3-liter twin-turbo power plant of the base models, or looking at the highly advanced T-hybrid declensions, the promptness in responding to the pilot's commands is immediate. The adoption of technologies inherited directly from track competitions, including the electrically managed turbo that completely eliminates turbo lag, ensures a vigorous and steady thrust at any engine speed. In the flagship versions, the mechanical exuberance unleashes over 500 or 600 horsepower, capable of burning the 0 to 100 sprint in about 3 flat seconds. Yet, true greatness is not measured solely by technical data sheets or the peak velocity of 320 kilometers per hour, but rather by the harmony between linear thrust and exceptional grip offered by the engine placement. Every acceleration delivers profound sensations, fusing pure energy and flawless management into an absolute benchmark for the world of supercars. Most people think just-in-time means low inventory, but for an engineer, it's about eliminating the waste of motion. Main components like seats and dashboards arrive not only on time, but in the exact sequence of the specific vehicles moving down the line. For standard hardware, we rely on internal supermarkets governed by the plan for every part logic. When a workstation consumes a part, an automated replenishment signal restocks only what was used. Zero buffer inventory, absolute efficiency. Inside Porsche's historic Zuffenhausen plant, component positioning for the 911 is a masterclass in smart factory logistics. Driverless automated guided vehicles transport parts and chassis smoothly across multi-level floors, while high-precision automation and skilled technicians seamlessly integrate each custom module just in time. Generating an efficient production layout begins with analyzing product demand, routing requirements, and process sequences using methods like from-to charts and material flow analysis. Guided by lean manufacturing principles, engineers minimize transportation waste by arranging workstations in sequential flow or cellular layouts. The goal is to balance line capacity against takt time, optimize floor space utilization, and ensure smooth, ergonomic material handling from raw storage to final assembly. Throughout the fabrication of the Porsche 911 skeletal structure, sophisticated robotic dispensers utilize heavy-duty, dual-component structural resins to fuse mixed material elements, uniting high-tensile steel with feather-light aluminum. This specialized bonding compound yields an outstanding tensile shear strength greater than 25 megapascals, matching the load capability of conventional resistant spot welds, while substantially elevating chassis torsional rigidity. By uniformly dissipating mechanical forces across each joint, this advanced adhesive method permanently improves impact safety, dampens operational vibrations, and eliminates galvanic corrosion between dissimilar metallic surfaces. Moving into the specialized zones, the dedicated engine assembly line. Here, activities are balanced to respect takt time, utilizing screw standardization systems and poker yoke mechanisms to completely eliminate assembly errors. While body assembly and painting are over 80% automated, final assembly retains a 60 to 70% human touch point. Operator ergonomics are supported by zero-gravity handling systems, reducing fatigue during complex insertions like dashboards and connectors. By analyzing our spaghetti charts, we evaluate time units and operator paths against tool placement, whether it's the custom leather shaping presses or the Cabriolet's hydraulic soft top installation. Craftsmanship and lean engineering work hand in hand. A Yamazumi chart is a lean manufacturing tool that uses stacked bar histograms to visualize and balance workstation cycle times. To interpret it, look at the horizontal line representing the takt time, which sets the exact pace required to meet customer demand. Your goal is to ensure every station's total stack of value-added and non-value-added work sits comfortably below this takt time line, guaranteeing that no operator is overloaded or facing bottlenecks. At the same time, stations should be adequately saturated close to the line to minimize idle time, ensuring a smooth, perfectly balanced, and highly efficient production flow. Efficiency isn't just about speed, it's about a zero-defect standard. Final inspection stations and rigorous quality gates ensure the Cabriolet maintains the exact flexural and torsional rigidity of the coupe. Now let's look at the bottom line. Thanks to stable volumes and high transaction prices, initial platform investments are fully amortized within the first 2 to 3 years of the model lifecycle. The return on capital employed for the 911 line is among the highest in the automotive sector, generating up to 30% of Porsche's total profits from just 11% of unit sales. If you want to master industrial engineering case studies like this, make sure to subscribe and drop a comment below. See you in the next engineering breakdown. The Porsche 911 Cabriolet represents an unmatched pinnacle of automotive craftsmanship and uncompromising quality. Beneath its sleek, electrically operated soft top lies a meticulously engineered chassis that preserves the legendary coupe's rigid driving dynamics without a hint of cowl shake. Every interior detail, from hand-stitched leather hides to flawless panel alignment, reflects a relentless pursuit of perfection. Built with precision in Zuffenhausen, the 911 Cabriolet seamlessly merges open-air exhilaration with peerless long-term durability and peerless luxury.